Hey everybody, let's have a look at the rules of exponents. Let's go over them again. It's very important, and that's why I wrote a nota bene over there, that you remember these. So when you have a to the n, it means that you multiply a times a n times. When you have a to the naught, any number to the naught equals 1. When you have a to the minus n, it means you have to say 1 over a to whatever power. And once again, 1 over a to the negative power means that you bring a up to the top and you change the negative to a positive. So let's do a revision of the exponent laws. Right here we've got a to the power of m times n, which means that you add your exponents. If you have a divide sign, you subtract your exponents. If you have a power to a power, you multiply your exponents to each base. If you have a power on top of a power, which is a fraction, both bases then get the power. However, if you want to bring your base at the bottom up, it becomes negative. Now, if you've got a to the m and it's got an exponent to the n, you multiply your m and n. This is always the case where you have a positive a and a positive b, and these numbers need to be real. Let's start with an example. If we have 2 to the power of 3x times by 2 to the power of 4x, we have the same bases, therefore we add exponents. So 3x plus 4x is 7x. Easy game. If you have a minus 2 to the power of 2x plus 1, you multiply minus 2 to 2x plus 1. As you can see, it's minus 2 times by 2x plus 1. We do FOIL, and we say minus 2 times 2x is minus 4x, minus 2 times 1 is minus 2. That minus means you need to take the base 2 to the bottom. So you have 1 over 2 to the power of 2, open bracket, 2x plus 1 with positive exponents. Easy game. Now let's look at, you've got 4 and 16. These are both numbers that 2 can be divided into. If we do the prime factors of 16, we see that you can get 2 to the power of 4. So we write 2 to the power of 4 to the power and times that by n. The divide sign means that when you bring the 2 to the 4 up, it becomes a negative. And now we've got all the same bases. So we can add exponents because everything's being multiplied together. 2n plus 2n plus 1 minus 4n. So the 2n, 2n, and 4n cancel, leaving you with 2 to the power of 1. That final answer is just 2. Easy game. Over here, we'll say 9 is the same as 3 squared because prime numbers of 9 are 3. 3 times 3 is 9. Look at that. Bring that down with the same exponents. Look at 15. Now 15 is 3 times 5. There's no squared signs, no cubed signs, and no exponents, except for the exponents from above. As you can see, it took the prime numbers of 15, and that's what you get. Right, now we carry everything down. We've got 5 to the power of 2x minus 1 times 3 to the power of 2, open bracket, x minus 2. So we put our 5 down, and then we carry our exponent down to the 5. We then do the same for 3 with a 2 to the power of x minus 2 in brackets. Take that across. Same goes for the 3 above that. We drop that 3, and we have 2 to the x minus 3. Now that 5 goes across there, and you take the power from that bracket. Right, so now we've got 5 to the 2x. With the rest of the exponents, we say 2x plus 2x is 4x, minus 1 minus 3 is minus 4. We do our 3 now. We do 2x plus 2x is 4x, minus 4 minus 3 is minus 7. Easy game.